the open box problem is one of my all-time favorite calculus problems. Although unfortunately for you guys who aren't in calculus yet, we can't use calculus yet, so we're going to use our calculators to find the answer to this question. So here's how it works. We have a flat piece of cardboard, and what I'm going to do is I'm going to cut out a square from each of the corners. And so what's left will be sort of this plus shape, this cross shape, and what I'm going to do is fold up the remaining sides to make an open box. So if you need a visual for what's going on, that's what these diagrams down here are showing you. I'm cutting out those squares, I'm folding up the box, and I'm making this open box, a box without a top to it. What I want to do though is I want to figure out what should I actually cut out, like what size square should I cut out so I get the maximum volume. Like I could cut out a little tiny square and I'd have a long shallow box, or maybe I could cut out a really big square from the piece and I have a tall skinny box. But what should I cut out so I have the maximum volume is the question. So like I said, this is a calculus question, one of my all-time favorite ones, but for us right now who can't use calculus, don't know it, let's go ahead and just use some algebra and our calculators to help us do this. So what I need to do is write an equation that represents the volume of the box. Well, so to find the volume of a box, it's going to be length times width times height. Okay, let's consider this the length of the box. So it's not 20 inches because remember I'm cutting out an X and I'm cutting out an X from either side. So the actual length of the box once it's folded up down here in this final diagram is actually going to be 20, but then I've subtracted off not just one but two X's because I'm cutting X out from either side. Okay, you get that? Let's consider the width to be this piece right here. Again, not all the way across. 16 is the length of the cardboard, but I've cut out an X from that side and that side. So my width of this box is going to be 16, again, minus 2X, because I've cut X out from either side. And then I need to figure out what the height's going to be. Well, this is hard to explain from just the video because I usually am describing it with my hands and stuff in class. But your height of the box, if you imagine it folding up, that distance we cut out, X, is going to be kind of what gets like flipped up and folded as the height of the box. So the height of the box is just going to be X. Again, if you need me to kind of explain that in person, ask me in class and I can show you why that works. This equation then is going to represent the polynomial, or is going to represent the volume of that box. So there's our polynomial equation. What we'll need to do now, since again we don't have calculus to use, we're going to have to switch over and we're going to use our graphing calculator to find the maximum volume from here. So let's switch over to our graphing calculators and finish this problem out. Okay, so I've gone ahead and typed in the polynomial we just wrote into my calculator. Now I've switched the order around a little bit, doesn't really matter. As long as you got 16 minus 2x, don't do 2x minus 16, that's not the same thing. But I've got all three pieces, the height, the width, and the length typed in, and all of them are being multiplied together. So we need to find the maximum height of this, or the local maximum of this polynomial. So I don't want to just use my standard window. Let's go ahead and adjust our window. Now one thing I really like is I love when I can make a perfect window. And so X is the amount of space I cut out, the length of that square I cut out. So let's use 0 because I could choose to not cut anything out, although I wouldn't really have a box then, it wouldn't be volume. The most I can cut out, think about it like this. Find your shorter side 16. And what's the most you could cut out from either end before there wouldn't be a box anymore? Some people say 16, but that's not right because I can't cut 16 that way and 16 that way. The most I could cut out from either end is just going to be 8. Now it's not necessary to have that number be perfect, but like I said, I like having a perfect window. I mean, why not? So if I cut 8 and 8, that's the most I could cut out before I started overlapping. Obviously, if I cut 8 inches out, there wouldn't be a box either because there'd be nothing left over there. Alright, so for your y then, your y represents the volume. The minimum volume is 0. That would be if I didn't cut anything, or if I cut 8 out, I'd have no volume. As far as the max volume goes, I really have no idea. I mean, I've already done the problem as you can see, and I've made a sketch. So I'm just going to guess at my volume. My highest volume. Now, if it's too low, like if I don't see the maximum, if I don't see the top of the polynomial, then I'll just make it bigger, or if I guess too big, I'll make it smaller. So this number is a total guess, and if you don't guess right the first time, that's okay, don't stress it, just try again. So let's take graph, and here's what I mean by a perfect window. Look at this, it starts out from the origin, it reaches the maximum, and then it kind of fizzles out, and then boom, it hits there right perfect in the corner. I love when I can get that figured out. So what I want to do, notice it's not a parabola, it's not perfectly symmetrical, it is definitely part of a polynomial. I want to find that maximum value right there. In a couple years, you guys will be able to look back at this problem and use calculus to do that. But for now, let's go ahead and just use our calculator. So second trace, we want to select maximum this time because we're trying to find a maximum volume. They're going to ask you those same 3 questions they always do: left bound, right bound, and guess. So move over here to the left and hit enter. Move over to the right of that high point somewhere and hit enter. And then finally hit enter for guess, and it should find your maximum value. So your coordinates are about 2.94, let's round to 2 decimal places, and 420.11. Before you finish the problem, though, make sure you interpret what those mean. Don't just list me the coordinates, interpret what it means and answer the questions. So they say, what should you cut out of each corner? Well, that's x. You should cut out a square that's 2.94 inches long on either side. And then what would the maximum value be? That's your y value. The biggest this box could be, the best cut, would be to cut out that much and get a volume of 420.11 cubic inches.